All right, class, welcome to Learning Outcome 9 PowerPoint presentation for Math 2015. In this outcome, we're going to correctly differentiate situations when one variable is sufficient from situations when more than one variable is needed. So we're going to take situations like word problems and model them with expressions. And the variables we choose in our expressions, we want to try to simplify as much as possible so that if we have many variables, we can try to get as few as we can. So it will simplify the calculations and such. Okay, so we're going to model with variables here and try to simplify our models with as much as we can. First, we need to write a scenario that matches with the expression x plus y. And when we write scenarios, it's important to know that each variable needs to refer to the same thing. Okay? But since we have a variable, the number of objects can vary, and we need to allow for that in our scenario. So with variables like x or a or n or y or z, we just say some of the objects, some objects. Okay? So here's a possible scenario for x plus y. And this is what I'll use throughout because we're going to do variations on it throughout this lesson. Okay, so one day, I went to the store and bought some apples. Okay, some apples is what I'm going to do for my x. Okay, some apples. I don't know how many. I just bought some amount. Now the next week I go to the store and I've eaten all my apples and I bought the same amount of apples because I need to do x plus x. Okay. So the next week I went to the store and bought the same amount of apples. Okay, the same amount is also my x value. Okay. Now y has to be different than x. Okay, and y could be a different amount of apples. So we're going to say the following week, I went to the store and bought a different amount of apples. Okay, so that's everything together. Now, I'm going to add x plus y. Now, the objects that the variables are referring to, the number of objects they're referring to is, okay, so the type of objects that the variables are has to be the same if you want to add them together. So y cannot be something like bananas or oranges. It has to be apples. X can vary, could be any number of apples, but it's going to be fixed, but we don't know. So x could be some amount of apples, the other x is in the same amount of apples, and then y must be apples as well, but it's going to be a different amount, okay, because y is a different variable than x. Okay. Now, if you go ahead and write a scenario and use a different situation, pause the video, and then when you can unpause it, we can answer this question. What do these scenarios have in common? Okay, so with your scenario, what does it have in common with mine? My guess is that you have some for x and some for y, the same amount for, and the same amount for the other x. Okay, some for the first x, some for the second x, and the same and some different amount for y. Okay. How would your scenario change if I changed the expression? Now we have x plus 2x. Okay, so this is how mine would change. One day, I went to the store and bought some apples. Okay, that's where my x is, bought some. Okay. The next week I bought the same amount. Same amount. The following week I bought twice as many as usual. Okay, twice as many. Okay, so that's where my 2x comes from. Okay, and here I've done weeks for my shopping because I don't want to keep buying more apples in the same trip. So I thought it would be more realistic to do week after week. But you can buy whatever you want on your trip, or you can use your x as some other variable, other idea, okay, and take care of it all at once. How would my scenario change for x plus x plus x minus 7? Okay, so one day I went to the store and bought some apples. Okay, some apples. The next week, I bought some more. The same amount. The following week, I bought 7 less than usual. Okay. So that's how that x minus 7 affects things. How are these scenarios different than the ones you built for x plus y? So in the first one that is modified, I had twice as many apples, 2x, as I did on the third week. The scenario is different this time because on the third week, I am buying 7 less than my usual amount. So they could be different values. Okay. What if x plus y equals 9? So let's take a look at this one. So one day I went to the store, rewriting my scenario, and bought some apples. Next week, I bought the same amount. The following week, I bought a different amount. Change this. Okay. Now the equals 9 means that that's the total of all the apples I bought. Okay. Okay, you could say something like, I bought 9 apples altogether, or there are 9 total, something like that. Now, what this does is that it puts restrictions on what x and y are. Okay, the 9 puts a restriction on what x and y are. And so, what could they be? Well, let's say that x equals 1. Okay, then x plus y must equal 9. Now my x is 1, so I'm going to substitute 1 in there. And because I set that equal to 9, I will have to know what y is. And apples are a situation where all I need to check are whole numbers. Therefore, 2 plus y is equal to 9. Therefore, y is equal to 7. Okay, so I could buy 1 apple 1 week and 1 apple next week, and then the third week I bought 7. Okay, we can explore this idea further by letting x equal 2. Then 2 plus 2 plus y is equal to 9. Therefore, 4 plus y equals 9. Therefore, y is equal to 5. Okay, I could have bought 2 apples the first 2 weeks and 5 the third. Let x equal 3. Then 3 plus 3 plus y is equal to 9. And 6 plus y equals 9. Therefore, y is equal to 3. I could have bought 3 apples each week. Would that work? Well, it depends on what your point of view is. If I let x equal 3 and y equal 3, that means I'm letting them be the same amount. So technically that probably wouldn't be able to work because I want to keep all of those numbers different. Okay, x is some and y is another amount. Okay, so these are the wonderful things that you can explore when you make the expression into an equation. Let x equal 4, then my 4 plus 4 plus y is equal to 9, which means that 8 plus y equals 9, therefore y is equal to 1. Okay, so those are my possibilities if y is equal to 9. So if I set my equation equal to a number, I restrict my possibilities. Okay. Let's go to the next one. Phil and Hannah are taking a road trip to visit their cousins. Phil drove some of the way, and Hannah drove some of the way. Let's write an expression that captures this situation. Okay. Remember what we talked about last time with variables is that variables need to equal quantities, a number of something. Now, if we want to drive, we're going to talk about some miles or something like that, or a distance, whether it be miles or kilometers or whatever. So if we want to do Phil and Hannah, they're each going to take turn driving some miles. P plus H is going to be added together to get to the trip. Okay, so this expression captures the situation for P is the number of miles that Phil drives, and H is the number of miles that Hannah drives. Okay, so if I just do P plus H, I need to kind of explain what those are. P is equal to the number of miles Phil drives. And H is equal to the number of miles Hannah drives. Okay, so P plus H is my equation, my expression, sorry. It's not equal to anything, so it's just expression. Okay, so we make sure that our variables are representing numbers, so number of miles, it's very critical. Let's go ahead and set that equal to something. So Phil and Hannah are taking the same road trip to visit their cousins, but we now know that they live 329 miles away. So Phil drives some of the way, and Hannah drives some of the way. Okay, so P plus H is equal to 329. Now, since I'm using P and H, I need to put down what they're equal to again. P is equal to the number of miles Phil drove. H is equal to the number of miles Hannah drove. Okay, so here's something that's interesting. Let's do an extra. You guys like extras, right? Extra thing to think about. With P plus H, and that's all. We're not going to set it equal to anything. That's like the last one. We're going to ask the question, what is the fraction of the trip Phil drove? Okay, so we're going to make an expression out of this. What is the fraction of the trip that Phil drove? Okay, so fractions are the part of what you want divided by the number of parts the whole is divided into. Okay, so we'll do that as an aside. Fractions are the part you want divided by the number of parts the whole is divided into. Okay, so the part that I want is Phil's miles. Okay, so what we're going to do is we're going to put P as the numerator, and the denominator is the total, the number of parts the whole is divided into. The whole is divided into P plus H, or the number of miles that Phil drives plus the number of miles that Hannah drives. Okay, so that's the fraction of Phil's driving. P divided by P plus H, or P over P plus H. Here's another extra. With P plus H equal to 329 now, what is the fraction of the trip that Hannah drove? Okay. So now we have a number to associate with the P and the H. You could do H over P plus H, or since we know what P plus H is equal to, we can do H over 329. Okay. So those are some fun extras that will probably be helpful later on. Okay, in this slide we have a situation to which we need to write an expression. And the expression could be a lot of things that we can write, but let's take a look at their situation. Tanya made some number of batches of cookies for the bazaar. Eric made some number of batches more than Tanya, and each batch makes 30 cookies, about. So we want to write some expressions that model the situation. And so there are a number that we could write, so you can go ahead and write anything you want. So let's go ahead and do that first. Have you guys write some expressions, and then you can pause the video while you do that, and then resume it again after you're done. So go ahead and do that. Okay, now that you've written some explanations or expressions, we are going to explore some here now. So first we're going to let T, so we need to mathematize each of these sentences by applying a variable to it, by creating a variable and applying it to it. T is going to equal the number of batches of cookies Tanya made. Okay, then we're going to let E equal the number of batches of cookies that Eric made. Okay. And so what can we say about these batches of cookies? Well, we can find the total number of batches if we want, right? Total number of batches. So you take the number of batches that Tanya made, adding up to the number that Eric made, and there's your expression. What else do they give us here? It's that Eric made some number of batches more than Tanya. So when we see some number and some number, okay, we can use those and write variables. So since Eric made some number more than Tanya, you can think about this here. Or in other words, since E is greater than T, we want to let X be the number of batches more Eric made than Tanya. Okay. So what we're going to get out of that is we're going to get that T plus some number X is going to equal E. Okay. So since Eric made more, you have to take Tanya's number of batches, add on the more that Eric made, and set equal to Eric's batches. Okay. What can we do? Well, we can also express the total number of batches, in a different way. Since before I said T plus E, and E could be T plus X, let's substitute in T plus X for E. So the total number of batches could be T plus T plus X, which is the same as 2T plus X. Okay. What else can we say? The last part is each batch makes about 30 cookies. Well, since we can know how many cookies are in each batch, we can actually find the total number of cookies. Okay. Since there are 30 cookies in each batch, the total number of cookies can be expressed as an expression, which is what you do is you take the total number of batches times the number in each batch. Okay, so we have multiplication, which is our groups of objects idea. Okay, groups of objects. So we're going to take the number of batches so the total number of cookies is equal to the number of batches that Tina made multiplied by 30 plus the number of batches that Eric made multiplied by 30, okay, which is the same as 30T plus 30E, to find the total number of cookies. Okay. So some pretty cool things that we can find out from our situations here. Let's go to another situation where we're going to do not just some more. Eric is making 6 more batches. Okay, so Tanya made some number of batches of cookies for the bazaar. Eric made 6 more batches than Tanya, and each batch makes about 30 cookies. So what we're going to do is we're going to kind of do the same setup as before, but we're going to see how the 6, now that we know that there's 6 instead of some more that Eric made, let's see how that affects things. So first we're going to let T equal the number of batches of cookies Tanya makes. we're going to let E equal the number of batches of cookies that Eric made. So the total, again, is going to be T plus E. Total number of batches of cookies. Okay. Since Eric did 6 more batches, okay, then Tanya, we can say, that Tanya's number of batches plus 6 is equal to the number of batches that Eric makes. Okay. Because of this, we know that the total number of batches is T plus E, but the main key for this lesson is that T plus E can be simplified because we have T plus 6 is equal to E with numbers here. Okay, we can now write the total number of batches with just one variable. By substituting in T plus 6 for E in the expression, in the equation, no expression for the total. For total number of batches. Which means we have T plus E is equal to T plus 6, which is equal to 2T plus 6 for the total number. Total number of batches. And if we want to find out how many cookies, we can take T plus E, multiply that by 30, because that's how many batches there are total, multiply by 30, and which is the same as 2T plus 6, multiplied by 30, which is equal to, when I distribute the 30, we can do 60T plus 180 total cookies. Okay. Here are 3 takeaways from the lesson. If a relationship between 2 quantities is stated, it is preferred to model the relationship with an expression in just one variable. So if you can, write one variable in terms of the other and then substitute it into the expression, that's preferred. If 2 or more variables are used in an expression, they should represent varying quantities, like our apples. X and Y represented both apples, but different numbers of apples. And it could be any number of apples. And when there's no stated relationship given relating the quantities, that means that when I didn't have any apples at the end of my shopping trips, they could be any number. But when I did have 9 apples at the end of my shopping trips, it restricted the number of apples in possible situations. Okay. The third is 2 different variables may have the same numerical value, but they represent different varying quantities. Okay. So it's kind of like with the debate between Well, should y equal 3 apples and x equal 3 apples? Well, they're different. Okay, so we don't want to consider that as much. All right, homework. Unit 2 homework packet number 15. And on next class, I'm going to post a video with some homework hints. So I hope you guys enjoyed this video. Let me know if you have any questions or if there's anything I can do for you. You can send an email or request a Zoom meeting.